Okay, Module 12 is called Inference. We're talking about inferential statistics, and what is that? And let me frame the question a little bit differently. Okay. It's estimation versus decision. In other words, there are two things that we're going to do in inference. We're either going to estimate and make a guess at what some value is. That's part of statistics. The other is using statistics or using the methods of statistics to give us a recommendation for making a decision. Okay? And we'll look at how we do that. Well, first of all, let's see, I got to refocus here. Okay. When we do estimation, what are we talking about? We're trying to do what is our best guess. In other words, if we're measuring something, what is the real average size of a population? Okay? We're trying to calculate X bar in the book. That's the sample mean. And we're going to use that as an estimate of what mu is, the population mean. That's what statistics is involved. Mu is a parameter. That is something that measures the whole population. And we're going to calculate a statistic, X bar. A statistic is a calculation from a sample that is used to estimate what the actual parameter is. And so we're going to, when we do this on confidence intervals, and this will be the next module, we're going to be figuring out what is our best guess, and then with that we have to answer how accurate is it. Well, the accuracy comes in the form of a confidence interval. A confidence interval tells us how good the number is. For example, we may have an answer like 10 plus or minus 2. That plus or minus 2 would be our confidence interval. It says you add 2 to 10, your top end would be 12, your lower end would be 8. So you know that your best guess is 10, but the real answer is somewhere between 8 and 12. And you have a degree of confidence. Normally, we use 95%. That is your default setting. So unless it's specified different, we do 95%. Sometimes you'll see 99% used, sometimes 90%. Very, very seldom. I've never seen any of the other than that used. But 95% you're going to see most of the time, and occasionally when you require a lot more precision, they'll use 99%. And some of the social sciences, when they're initially looking for relationships, they'll go with 90%. Now, how do we calculate this? If we're dealing with a normal distribution, what we have to do is figure out how do I get 95% in the middle. I'll do this. What it means is if we have 95% in the middle of the distribution, we're going to have 2.5% to the top and 2.5% to the bottom. If you remember how we calculated things, the normal table gives you the less than. Let me put up the normal table. Okay. If we go to, if you notice here in the percentages, if this is dealing with the left-hand side of the distribution, if we have 95% in the middle, we would have 2.5% on the bottom and 2.5% on the top, so that they would all add up to be 100%. When we come to look at that, we look up in the middle of the table. Remember, when they give you a percentage, you have to look up from the middle of the table outward. We look in the middle of the table for the value 0.250. And so if we're going through and looking for it, 0.250 is right about here. Okay, and what does that turn out to be? If we look to the left, it's minus 1.9 standard deviations. And you look up at the top, and it's 0.06. So that means minus 1.96 standard deviation gives me 2.5% to the left of the distribution. if I look to the right, let me find the other paper. Okay, here's the other one. Okay, now we get the part to the right. If I want 2.5% to the right, how much is to the left? It has to be 97.5%. So let me move this table down, and we will go look for 97.5%. Okay, let's go find 975. It is right here. Okay, this is 1.9, a plus 1.9, and if we go up to the top, it's 0.6. Again, we have a plus 1.96. And this is where we say that if we put up the table that we had before, for 95% confidence, we need 1.96. It's plus or minus 1.96. Similarly, when we do the confidence intervals, you'd find that for 99% it's 2.574, and for 90% it's 1.645. I remember these because we use them so often. These are your normal values. Now, what happens if we don't have a normal distribution? If it's off from that? This is where we will take and add a fudge factor in. That's where the t-table comes in. The t-distribution is your normal distribution adjusted for the problems that come up with smaller sample sizes. Okay? It was found by a guy by the name of Bill Gossett. He did the work at Guinness Brewery. He was a quality control person. That sounds like a great job. He sampled Guinness Stout for a living all his life. And he developed the tables as far as at how far off are the normal tables when you're going with a relatively small sample size. And he built the tables that tells you, you say what the sample size is, and you figure out how much you have to add to the normal table. Okay? And doing that, adjusting for the sample size, is what they call figuring out the degrees of freedom. So when we do t-tests, you look at the size of the sample. For example, if you have 25 items in your sample size, you take n minus 1 or 24. That would be your degrees of freedom. You would use the 20. You'd go to the 24 line in the t-table. I will go over this in detail when we do the t-distributions, but for right now, this is what you need to know about it as far as that when we're doing it. So when you're estimating, you will come up with a sample mean, and you have to give the fudge factor, not the fudge factor, but the margin of error that goes to the top and to the bottom. And so you're always going to give things in terms of a confidence interval, which is your mean plus or minus the margin of error. And so let's run through that again, okay? So your mean plus or minus the margin of error. So if you have a normally distributed population and you want 95% in the middle, you have to use 1.96. So you take your mean and you go 1.96 standard deviations above the mean and 1.96 standard deviations below the mean, and between those two numbers you have a 95% chance of having your mean fall within that. And that's what a confidence interval is. If you want to have a 99% chance, you have to go further out. If you want a 90% chance, you can pull in further. And that's where the 2.574 and a 1.645 comes in. Now, how do we make decisions with this? And I would just quickly go on to this. I don't have it written down. I'm slipping on here. Okay. Let me just put it in this way here. Okay, to make a decision, the math is the same as you're doing for confidence. And what you're doing is setting up a test. We'll call this hypothesis testing, and this is going to be another module by itself. And what you're doing is to see if the mean of your test sample. So you take a sample and calculate the mean of that sample. And if it lies outside the confidence interval, then you say something happened. This is what we call significant change. In other words, it wasn't where it was supposed to be. You take this as a suggestion that, or a proof that there is something that happened. And we call that significant change. Okay? And this is what we're going to be doing when we're setting up making a decision. We do hypotheses. You will do the math the same way as you do a confidence interval, but what you're doing is looking at, does my sample mean fall inside of the confidence interval or outside the confidence interval? And if it falls inside, we say, well, nothing changed. There's nothing significant there. If it falls outside the confidence interval, we say that then that is evidence of significant change, and we say that the mean has changed significantly. That would be the alternate hypothesis. Again, we will do this in another module. That's it for this.